Then I'll continue in Turkish. And our center is established with the collaboration of industry and university, and this is supported by the government as well. And with the collaboration of industry, and this is used by the industry. And with high technology, if you need high technology, then the center can also train the employees. And well, this is our center, Sabancı University, or Integrated Manufacturing Technologies Research and Application Center. It is SUIMC, and in the same building we have production centers, so we are under the same roof, and there is the raw material. It is developed and manufactured here, and we are able to test, design, and also prototype and optimize all of these processes, and that is why we call it Composite Integrated Manufacturing Technologies Center. It is our vision to produce and manufacture high value-added integrated manufacturing and composite technologies. And according to our mission, well, some companies think that we are an R&D center for Corsa, but we are developing and making use of high technology with our industrial partners via our open innovation principle. And during the testing, during the optimization, we are developing the processes together with our engineers. So we are trying to create synergy between the industry and academia. And normally the universities are working in TRL 1 or TRL 2, but our mission is to reach up to the prototype level used by industry, and together with the industry we would like to have cost efficient production, and they will not take it and they will produce it. They will first have process optimization, and the industry can take and make its own investment and be able to use it. Well, there are many investments, but some of the technologies are not cost efficient. That is why they do not use this innovations or investments. Well, we have these laboratories and facilities in our center, and we are also we also own EAS 9100 certificates and ISO standard, and we have the accreditation and quality assurance, and we are one of the top 3 R&D university centers, and we are only in Turkey, and we are also the first one after the one R&D center in UK. Well, we start from the design and analysis of the composite materials, and the companies come and we design composites, and we optimize and analyze them, and we design for automated fiber placement. We have variable stiffness, and not only for fiber orientations, we can direct fiber, and we can design, and we have this very experienced analysis team for the composite design. And starting from the selection of the materials, we can develop design, and we can have computational fluid dynamics, and we have the topology optimization. And for the advanced composite manufacturing, we have autoclave, infusion, oven manufacturing, and mold conditioners. We can apply all of these options in our facility. We have 3-meter autoclave, and for the aviation sector and for the aircraft sector, we can develop parts and pieces. We do not establishing these projects for R&D purposes, but we are working with different companies directly, and we have our projects with these companies. Well, we have hot press as well. This is one of the production options, and we have different production options. We have hot press, and we also have heating processes, and we have 3D printers, and we have polymer printers. We have thermoplastics, we have thermosets, and we have robotic and unconventional machining, and 5-axis machining robot is working together with the water jet routing robot. And we also have polymer additive 3D manufacturing robot, and our robots can work in a synchronized fashion. And we have our 3D manufacturings, and you see these jets, but generally they are 2D, but we are able to cut 3D pieces with this technology. And this is automatic fiber placement machine, and we are the only university that can use thermoplastic and process parameters, and we can do all of these options simultaneously. We can have 6 kilowatt laser, and we can use it directly up to 7 meters. We can produce the parts, and we are working together with Corsa and Boeing, and this is commercialized as well. And we have all of the materials for the use of TUSAŞ. So this is a very good example for the cooperation with the industry. And there are different scopes for work. I'll skip this part. For the additive manufacturing, we also have EOS M290 selective laser melting machine, and we have hybrid process deposition and machining system, and this is SLM machine, and we can have a DD production. You can take different metal parts and you can produce them all together. You can take functionally graded material with different dusts of metal, and this is the only machinery that can produce metal dust conditionally, and you can have complex materials with the additive manufacturing. And we are actually collaborating with the engine companies. We cannot actually publish the work and the projects that we do together with the companies due to the privacy, but you can see them, 3 different companies, and we have polymer processing, and we have twin screw extruder and palletizer, and we have high shear stress compound preparation. We also have mini extruder, and we have blowing extruder. and these are antibacterial. There are different types of materials, and we can use and apply them in our laboratory. And we do also have material characterization laboratory, and this is, I think, the most developed material characterization laboratory, not only in Turkey but also in Europe. We can have Fourier transform infrared spectroscopy. If you have the chemical background, then you will know that there are different laboratories, but these are all under the same roof, that you can test their aspects and their features, and you can have dynamic mechanical analysis, and with the FDI analysis you can also detect these materials for the resins, for twin drive. For example, we have SPDAC, and we have differential scanning calorimetry for cooling. And I think that this is the only machinery in Turkey, and it can go up to 2 million degrees and even 1500 degrees, and it will show the effects of the material. Now also we have mechanical tests, structural health monitoring laboratory. We have tension tests, and we have multi-axis fatigue and torsion tests. Fatigue and torsion tests can be applied simultaneously in this system, and this system has certification. We have our qualified personnel, and the students can do their own tests, but when we work together with the companies, all of these machines are used by the qualified personnel, and it is not easy to choose the personnel. You can buy the device, but it is really hard to train the personnel. But now we have this capacity. By the way, we were established in 2016. We are 6 years old now, but we have accomplished many projects so far. We have our mechanical test and structural health monitoring laboratory. We have 4-channel acoustic emission system based on PCI 2 board, and we have our Photonic and Torlabs laser sources, and we have thermography, we have acoustic imaging, and we can detect with these cameras where is the fracture, where is the crack. We can detect it, and we can even say the lifespan. We have this infrastructure, and over 95% we are able to provide all the mechanical tests. I should say that the mechanical test laboratory and material characterization laboratory are complementary to one another. And again, in wet chemistry laboratory, we have most of the chemistry tests, and we have developed our own system. We have our functional materials, and we have semi-automatic grinding and polishing machine. For example, we have flame retardant materials together with Costra, and we can say that this is like a general chemistry laboratory. We have the resin formulations, and for the flammability laboratory, we are testing cone calorimeter, multipurpose Bunsen burner testers, and smoke density and toxicity chamber. And for composite material, we have the composite design, analysis, and manufacturing. So if you do not know of them, if, for example, if they will be cut in this way. Well, this is very important know-how, and we have our professors, and we have 11 professors, and we have 90 masters students, and other than that we have 50 PhD or master students, and we have over 160 personnel in total. We have nano and micro materials, and I already mentioned the polymers, and we have the thermomechanical stress and fracture analysis, and we are working for functional polymers, as I just said, while we have health monitoring of composite structures with IFEM, and we have the design and synthesis of graphene and hybrid additives for various applications, and we have a company for this. Well, this panel was a sustainability panel, and we can produce our graphene with the waste material.
Pedal mevcut. Yine Renault otomobiller için şu anda ticarileşmiş. Grafen
For Renault automotives, graphene added products are available, and it is more stronger than the others. And we have some other works together with Ford. And again, about the thermoplastic materials, you know, they're very much used in the aerospace industry. We had so many works ongoing in there, and again we have other occasional projects. And this fiber, if you just have a certain orientation for the fibers, then you have an accurate amount of the strength and resistance, and that is what my PhD was. And there we have worked on this, and how we could do the body of the plane lighter was the focus, and we have managed to do it by 50%. So what we have done is we have oriented the fiber, because in every point the load that is that the structure is exposed to is different in every different point. Therefore, this is about the automatic fiber machine has done it for us. So we did the optimization for this, and we have the academic work, ongoing work in this regard. Now again, with respect to the processing of the composite materials and the robotic works about the repair of the composite materials, that is another one. And again, about the plasma activation. And the optimization, as mentioned. This is a very much preferred method with a very strong resistance. These parts have been all produced. And again, you see this addition. It's not a big problem now to stick them to each other. But as I say, thermoset or the composite material being integrated with metal is a major issue that we're working on at the moment. And a three-dimensional composite material work is an ongoing one. And the fresh strength. Composite leaf is, and how they've been manufactured and how they are tested together with Corsa. And we worked with these on their side, and the process optimization and how they're going to be produced and how they're going to be oriented, and their design analysis and the tests afterwards have been all done together with our commercial company, and they're all ready for commercialization at the moment. And again, as I said,
We have so many parts production on one side. So there are so many different types of production materials, and you are able to achieve some enforced materials in this regard. Well, again, we have this residue stress related to thermal stress. Topology optimization is another area of interest for us. The hybrid processes and the material development. And our presentation has been done with the Nanotechnology Center. The material works by the professors. Characterization and functional nano materials, synthesis, and the reactors, starting from monomer. And again, synthesizing is another important area where we can have different types of membranes. So many topics have been all studied in our center. And again, we would like to increase the university and industry cooperation. Therefore, we would like to kindly invite all the industrial organizations to come to us. Corsa is a client to us. It is not a center of Corsa. It belongs to Sabancı University, open to the whole university. It's a research application center, including all other universities. We invite everybody to come to us to focus on technology development, and we're there to support you in every kind of research project. And we're very open to this, and I'd like to highlight this. Thank you very much.